Okay, in this video I'm going to show you how to solve another 3x3 system of equations. So here we have three equations and three variables, x1, x2, x3. First thing you do obviously is you write the augmented matrix, and I think you're all probably pros at that right now. It's not difficult to do. So here's the augmented matrix. Now I'm going to start with that augmented matrix, and remember I want to have a 1 right here. That's the first step. And so, you could obviously multiply this row by 1/2 to make that a 1. But I spy a 1 down here below it. So what would probably be smarter would be just to swap row 1 with row 3. So we're going to do that row operation, and that's a simple row operation. And so I think most everybody knows how to do that. And so all we have to do next is figure out a way to use this 1 to eliminate the 3 and the 2 below it. So I like to circle this number that I'm pivoting on. So I want to multiply this 1 by -3 and add it to row 2 so that it'll cancel that 3. So when I do that, let's write down what the results would be. This is on scratch paper. So 1 times -3 is -3. -3 times -3 is +9. And 2 times -3 is -6. And of course, 0 times -3 is 0. So if we take those values now and add them to row 2 to complete this row operation, then -3 plus 3 gives me 0. 9 plus 1 gives me 10. -6 plus -1 gives me -7. And then 0 plus 7 gives me 7. Okay, so now I'm at this point of my problem. And I'm sorry, I still got another row operation to do. I still have to get rid of the 2. So I need to get rid of this 2. So to get rid of the 2, I'm going to multiply row 1 by -2 and add it to row 3. So I'll perform this row operation next. So let's see. If I multiply 1 by -2, I get -2. If I multiply -3 by -2, I get 6. If I multiply 2 by -2, I get -4. And again, if I multiply 0 by -2, I get 0. So now I want to add these to row 3. So -2 plus 2 gives me a 0 there in row 3. And then 6 plus -2 gives me a 4. And then -4 plus 1 gives me a -3. And then 0 plus 3 gives me a 3. So now I'm at this point of the matrix. So I've got the 1 here and the zeros at the other entries in that column. So I need a 1 right here. So I need a way to make this a 1. So what I'm going to do is I'm just going to multiply this row 2, by 1/10, and not sure why there's a negative. It shouldn't be a -1/10. So let's get rid of that. So I'm just going to multiply this row by 1/10, and then so 0 times 1/10 would be 0. 10 times 1/10 would be 1. -7 times 1/10 would be -7/10, and then 7 times 1/10 would be 7/10. And so now that gives me the 1 there that I wanted. And so the next step would be to eliminate the -3 that's above it. So if I multiply this row by 3 and add it to this row, it'll cancel the -3. So that operation will be 3 times row 2 plus row 1, putting the result in row 1. So let's see, what would I get if I multiplied row 2 by 3? Obviously, if I multiply the 0 here by 3, I get 0. If I multiply the 1 by 3, I get 3. Now this is where it gets a little tricky. -7/10 times 3 is -21/10. And then 7/10 times 3 is +21/10. Okay, now I have to add these values to row 1. So 0 plus 1 would give me 1. 3 plus -3 gives me 0. Okay, now here you got to do a little bit of math. 2 is actually 20/10. So remember that 2 is 20/10. So I'm going to take negative 21 over 10 and add it to 20 over 10, and that's going to give me the negative 1 over 10. Okay? And then 21 over 10 plus 0 is just going to be 21 over 10. All right, so that eliminates the 0 above the 1. Now we need to eliminate the 0 below the 1, so I'll have to multiply row 2 by negative 4 and add it to row 3. So let's see what would happen if I multiply row 2 by negative 4. Well, the 0 wouldn't change. If I multiply 1 by negative 4, I'll get negative 4. Now if I multiply negative 7/10 times negative 4, negative times a negative is positive, so that would give me 28 over 10. And then if I multiply 7/10 times negative 4, that would give me negative 28 over 10. Okay, so now I want to add these to row 3. So 0 plus 1 would be, 0 plus 0 would be 0. Negative 4 plus 4 would be 0. Now 28 over 10 plus negative 3. Now again, you need a common denominator, so 3 is the same as 30 over 10. So this is 28 over 10 minus 30 over 10, which is negative 2 over 10, which actually reduces, negative 2 over 10 reduces to negative 1/5. So if you need to, just do that on scratch paper. 28 over 10 minus 30 over 10, and then you can get negative 2 over 10 and reduce it to negative 1/5. All right, and then here I have negative 28 over 10 plus 3. Well, this is just the opposite, because see here I had 28 over 10 minus 3. Here I have negative 28 over 10 plus 3. So that's just going to be negative 28/10 plus 30/10. So that's going to be positive 2/10, which reduces to positive 1/5. Okay, so now I have to make this right here. I have to make this be a 1. This right here, a 1. So what I'm going to multiply by is negative 5. So the reciprocal of negative 1/5 would be negative 5. So multiply everything in row 3 by negative 5, and you get 0 times negative 5 is 0. This 0 times negative 5 is 0. Negative 1/5 times negative 5 is 1. But then 1/5 times negative 5 is negative 1. And so now I have the 1 here. And so what I need to do is I need to multiply this by 1/10 so that when I add it to this row, it cancels it. So let's just take a quick look at what happens when I multiply that row by 1/10. 0 times a tenth is 0. Same thing, 0 times a tenth is 0. 1 times a tenth is 1/10. And negative 1 times a tenth is negative 1/10. Now I have to add these values to row 1. So 0 plus 1 is 1. 0 plus 0 is 0. 1/10 plus negative 1/10 is 0. And then negative 1/10 plus 21/10, that would be 20 over 10. But 20 over 10 reduces to 2. Okay, so that means I get a 2 there. Now, to get rid of the negative 7/10, I'm actually going to multiply by this row by positive 7/10. So if I multiply row 3 by positive 7/10, the zeros would still be 0, but this 1/10 would now be 7/10, and the negative 1 would be now negative 7/10. So now I have to add that result to row 2. So let's 0 plus 0 is 0. 0 plus 1 is 1. 7/10 plus negative 7/10 is 0. And negative 7/10 plus 7/10 is also 0. So now I have my matrix in reduced row echelon form. So I have 1, 0, 0, 2, 0, 1, 0, 0, 0, 0, 1, negative 1. So that tells me that x1 is 2, x2 here is 0, and x3 is negative 1. Okay, so that's how you solve a larger system. And if you have to solve a system larger than 3 equations and 3 variables, you might as well use technology to do that. So I'm just going, that's as large as I'm going to go here. Okay, so on this one, what I'm going to do is I'm just going to show you what would happen if the problem had turned out like this. So let's say you did a problem, let's say you solved a problem and your final matrix turned out to look like this. So let's say you had 1, 0, negative 3, 13, 0, 1, 1, negative 6, and you had just a row of all zeros on the bottom. Now remember, if you had a row of zeros here and then a number other than 0 here, then that would tell you there's no solution. But in this case, this would just be a row of zeros, and all that tells me is that 0 equals 0. So I'm going to have a dependent system for this one. So let's take a look at what row 1 tells us. Row 1 tells us that x minus 3z equals 13 and y plus z equals negative 6. I'm going to assume the variables were x, y, and z. Alright, now if you take this and solve it for x, you can see that x depends upon z. So x would equal 3z plus 13. And if you solve this for y in terms of z, you'll get y equals minus z minus 6. And z, of course, we can just say is z. Z is actually the variable that these other two are going to depend upon. So what I can do is I can let just z be z, and then that tells me that x is related to z in this way. X is 3z plus 13, so I write that for x, and y is minus z minus 6, so I write that for y. So my three values are x equals 3z plus 13, y equals minus z minus 6, and z equals z. Now, if you don't like using z, you could use any letter you want. We could use k, but still if I use k, then x would then be 3k plus 13, and y would be minus k minus 6. And these represent infinitely many solutions because k can be any real number. There's a couple of practice problems down here, but actually I believe the answers are backwards. So you can, this actually should be the answer to this problem, and then this answer here should be the answer to this problem. So I'm going to go ahead and fix that in the notes that when I put them online in the course. But just be aware that the solution, when you do these two practice problems, the solutions are actually, I've got them written down backwards by mistake there. Okay, I'm going to finish up this section with one more video on some application problems. So make sure you check the video out on applications.